Hello friends, welcome to Maths Practice. Hope you have seen the last video on coordinate geometry. We had discussed the distance formula. In the second part, we will discuss another important formula which is called the section formula, midpoint formula, some very important examples which can be asked in the exams and also case study type of example. So do subscribe to Maths Practice. Like we had the distance formula in which we found the distance between 2 points, we have another important formula called the section formula. When a point divides a line segment externally or internally in some ratio, we use the section formula to find the coordinates of that point. That means suppose the coordinates of a point C are x, y, which divides the line segment joining points A, which has coordinates x1, y1, and B, which has coordinates x2, y2 internally in the ratio m is to n. Then the coordinates of C will be C xy is equal to m into x2 plus n into x1 upon m plus n, m into y2 plus n into y1 upon m plus n. A part of the section formula is the midpoint formula. Now, what do you mean by midpoint? A midpoint means a point which divides the line segment into two equal parts. So, what would be the ratio for that point? The ratio would be 1:1 because it divides into two equal parts. So, the coordinates of the midpoint P of the line segment joining points A, x1, y1 and B, x2, y2 is given by, midpoint is given by x1 plus x2 by 2 and y1 plus y2 by 2. Remember in the section formula we had taken the ratio m is to n. Here when we take the ratio 1:n, we get this formula for midpoint, which is x1 plus x2 upon 2, y1 plus y2 upon 2. Like for example, it is shown over here. If suppose one of the point is 4, 1, another point is 10, 5, we want to find the midpoint of the line segment joining these 2 points, then it is nothing but 4 plus 10 upon 2, 1 plus 5 upon 2. So 7, 3 is the midpoint of this line segment. Now we will take some examples which will give you a clear picture of how to use the section formula. Find the coordinates of the point which divides the line segment joining the points 4, -3 and 8, 5 in the ratio of 3:1 internally. Now this is the simple application of the section formula. Internally means the point which we have to find out lies between these 2 points which are given. So now suppose that let Pxy be that point. Let us list the data which we have given. Here x1 is 4, y1 is -3, x2 is 8, y2 is 5. The ratio m is to n is 3:1, means m is 3 and n is 1. Now we simply use the section formula mx2 plus nx1 upon m plus n, and the y coordinate is given by m y2 plus n y1 upon m plus n. You will see that when we put the values, we get x as 7 and y as 3. That means 7, 3 is the required point which divides the line segment joining the given points in the ratio 3:1. Now, example 2. Remember friends, we'll be doing all the different kind of examples which can be asked from the section formula. So try to understand each of them. Example 2, A 3, 5, B 2, -7 and C are collinear points such that BAC and BA is equal to AC. Find the coordinates of C. Now collinear means they lie in the same line. And it is given BAC means BA and C, they lie on the same line and in the order of BAC. So I have drawn the line over here, line segment. B has 2, -7, A has 3, 5, and since it is BAC, C has the coordinates xy which we need to find out. But one more thing is given, that BA is equal to AC. That means A is the midpoint of BC. So now over here we will use the midpoint formula. Midpoint formula is, the midpoint is given by x1 plus x2 by 2 and y1 plus y2 by 2. x1 is 2, y1 is -7, x2 is x which we need to find out, and y2 is y, and midpoint is given over here which is 3 and 5. So 3 is equal to x1 plus x2 by 2 and 5 is equal to y1 plus y2 by 2. Putting the values, we get x is equal to 4, y is equal to 17. Hence the coordinates of C are 4, 17. Example 3. Find the ratio in which P minus 4 minus 1 divides the line segment joining A minus 7, 5 and B minus 2 minus 5 from A. So here we need to find the ratio M is to N. So let the ratio be M upon N. Also we are given that it is from A. That means you have the first point as A, then the point which divides, which is P, and then B. So you have A, P, B. Now the coordinates of A are minus 7, 5. So x1 is minus 7, y1 is 5. Coordinates of B are minus 2, minus 5. So x2 is minus 2, y2 is minus 5. And the point which divides, it has the coordinates minus 4, minus 1. So x minus 4, y minus 1. Now we use our section formula over here. Here what is unknown? M and N are unknown. So we just put the remaining values. So we get the equation. From the first equation what we get is 2m is equal to 3n, or m upon n is 3 by 2. Remember here I have used the first equation. Also if you use the second equation you will get the same ratio m upon n as 3 by 2. Hence the required ratio is 3:2. Example 4. Find the ratio in which x-axis divides the segment joining A 3 minus 2 and B minus 6 4 from B. Also find the coordinates of the point of division. Now first what we are given is x-axis divides the line segment joining the 2 points. So since x-axis divides the line segment, that point of intersection will have the coordinates of the type x0. Correct? So now firstly, so whether it is possible or not. See, A is in the 4th quadrant from the given points and B is in the 2nd quadrant. So x-axis can divide the line segment in AB. Correct? Now let the point of intersection be Px0 and the ratio in which P divides AB, let it be m:n, and it is given from B. So now we have B, our point of intersection, and then you have A. Now over here BP upon PA is equal to m upon n, the ratio. x1 is minus 6, y1 is 4, x2 is 3, y2 is minus 2. This is given. Now again over here we do not know the values of m and n. We have to find that ratio. Okay. This is like the previous example, but over here x-axis divides. So the required point will be of the form x0. Now putting all the values over here, we get equation from the second equation. First of all we get is m upon n is 2:1 or 2 upon 1. Now when we put m is equal to 2n in the first equation, what do we get? We get the value of x as 0. Hence the x-axis divides AB in the ratio 2:1 and the point of division in this case is the origin, which is 0, 0. X is 0, obviously y coordinate will be 0. So our required point is 0, 0. It is not always that the point of division is origin. In this example we are getting the point of division as the origin. Similarly, you can also be asked for y-axis. If it is asked for y-axis, our required point will be of the form 0, y. Example 5. Find the fourth vertex D of a parallelogram ABCD whose 3 vertices are A minus 2, 3, B 6, 7 and C 8, 3. Here we will use an important property of parallelogram, that the diagonals of a parallelogram bisect each other. So here the diagonals will be AC and BD. D is that unknown vertex which we need to find out. Now let the coordinates of D be xy. By the midpoint theorem, the midpoint of AC and BD will be the same. To find the midpoint of AC, formula is x1 plus x2 by 2, y1 plus y2 by 2. So use the coordinates of A and C and find the midpoint of AC, which we get as 3, 3. That will be same as the midpoint of BD. For finding the midpoint of BD, coordinates of B are given 6, 7 and coordinates of D are x and y. So now when we equate both this, we get the value of x as 0 and the value of y as minus 1. Hence the fourth vertex of the parallelogram is 0, minus 1. Example 6. Show that the point P 5 minus 3 is one of the 2 points of trisection of line segment joining the points A 7 minus 2 and B 1 minus 5. Also find the other point of trisection. Trisection means they are the points which divide the line segment into 3 equal parts. The 2 points of trisection is the point which divides the line segment in 3 parts. So what will be the ratios? You have 3 equal parts. So the ratio for the first point would be 1:2 and ratio for the second point will be 2:1 since it divides into 3 equal parts. To find the points of trisection, we will use one by one both the ratios. When we use the ratio 1:2 means M is 1, N is 2, we use the section formula. We are given x1 7, y1 minus 2, x2 1, y2 minus 5. So this will give, using the section formula, value of x as 5 and y as minus 3. So the first point of trisection is 5 minus 3. Similarly, when we use the ratio 2:1 means M is equal to 2, N is equal to 1, we get x is equal to 3 and y is equal to minus 4. So the other point of trisection is 3 minus 4. Looking at the points also, you can very well check that they are the points of trisection because see, you have A as 7 minus 2, correct? Next point is 5 minus 3 means A is decreasing by 2, y is also decreasing by 1. Then next point is 3 minus 4 and then you have 1 minus 5. So it is in that order you have got the points of trisection. Friends, in one of the videos I had given the examination pattern. So now you can be asked some long questions or some case study type of questions. So let us take one example for that. Suppose if Arun starts walking from his house to office. Instead of going to the office directly, he first goes to a bank, from there to his daughter's school, and then he reaches office. Now what is the extra distance travelled in reaching the office? Assume that all the distances are covered in straight lines and the coordinates for house are A 2 4, for the bank it is B 5 8 and for the school it is C 13 14 and office it is D 13 26. All the coordinates are in kilometers. Here you will be needing root 5. You can take the value of root 5 as 2.236 or you also know to find how to find the value of root 5. Now we have just drawn the diagram. So suppose the first point is his house, then from house he goes to bank and from there to daughter's school and then reaches office. So you have 4 points over here. Now to find how much extra distance is covered, we will find the distance between all the pair of points. Now over here we know the distance formula. We had seen in the last video the distance between 2 points is given by x2 minus x1 whole square plus y2 minus y1 whole square, the square root of that. Now over here AB is 5, BC is 10, CD is 12. This is obtained just by putting the values in the above distance formula. Hence the total distance covered is 5 plus 10 plus 12, correct? You have home to bank, bank to school and school to office. So the sum of all the 3 distances is 27 kilometers. Now suppose if we had gone directly to the office from the house, the direct distance would be between the first and last point, means house and office, AD. So again using the distance formula, AD square is 13 minus 2 whole square plus 26 minus 4 whole square, which gives 605. So AD is square root of 605. Now that is equal to 11 root 5. You can put the values, you get it approximately 24.596. So the extra distance covered is 27 minus 24.596, which is 2.404 or approximately 2.4 kilometers. Now some assignment examples on the whole chapter coordinate geometry. Friends, please do solve these examples. I have given the answers also. And if there is any query, put in the comment box. This will help you a lot. Example 1. Find the ratio in which the y-axis divides the line segment joining the points 5 minus 6 and minus 1 minus 4. Also find the point of intersection. Since y-axis divides, the point will be of the form 0, y. So here the answer is 5:1 is the ratio and the point is 0 minus 13 by 3. Find the area of a rhombus if its vertices are 3, 0, 4, 5, -1, 4 and -2, -1 taken in that order. Now here again we use a property that the area will be given by half into the product of its diagonals. So now you can put the values. The answer is area is 24 square units. Example 3. If point P a by 3, 4 is the midpoint of the line segment joining the points Q -6, 5 and R -2, 3, then find the value of the unknown A. So this is just using the midpoint formula. Answer is A is equal to -12. Example 4. If A 1, -2, B 2, 3, C A 2 and D -4, -3 are the vertices of a parallelogram taken in order, find A. Now again use the property over here like we have used in one of the examples, that the diagonals of the parallelogram bisect each other. So using that we can get the value of unknown A as -3. Example 5. Show that the points A -6, 10, B -4, 6 and C 3, -8 are collinear, and also show that AB is equal to 2/9 AC. In the last video we had seen if 3 points ABC are collinear, AB plus BC will be equal to AC. So just use this and you will be able to prove that AB is equal to 2/9 AC. See, we have seen the internal section formula. In the starting I had said that the point which divides the line segment can divide it internally or externally. You just have the internal section formula in the syllabus this year. But suppose if external section formula needs to be used for further studies, you can use it as given over here. Suppose A x1, y1, B x2, y2 are 2 points and the point P divides this line segment externally, means it is outside AB, and suppose the coordinates of P are x and y, the ratio AP is to BP is m is to n. Then the coordinates of Pxy are given by mx2 minus nx1 upon m minus n and my2 minus ny1 upon m minus n. Now one more formula which is based on the distance formula. We can also find the area of a triangle if 3 points are given. Remember, this formula is not there in the syllabus this time, but again this can be used in further studies. So suppose if you are given 3 points A x1 y1, B x2 y2 and C x3 y3, then the area of the triangle formed by these 3 points is given by half into x1 y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Friends, in the last video we had seen the distance formula and we have seen the section formula in this video, and we have also seen all the important examples based on that. Hope you have understood them. So please do like and share the video and subscribe to Maths Practice. Thank you.